estimate the derivative of the given function numerically versus algebraically. Let's do algebra first. So we have x squared plus x plus 3. When x is equals to 2, you plug in x equals to 2 to get y equals to 9, and then you have a point 2 comma 9, and then we follow the limit definition of derivative. Limit as h goes to 0, f of a plus h minus f of a divided by h. So the a plus h, a is equals to 2, so we have a equals to 2. A equals to the given x value, then this is f of, you know what, I'm going to save one step. I'm going to change the a to a 2. How about that? I'm going to change the a to a 2 to save one step, and then I can just plug in the 2 plus h to the x, so that is a 2 plus h squared plus 2 plus h plus 3. That is your 2 f of 2 plus h, and then minus f of 2. So f of 2 is right over here, so that is just a 9, and then you divide it by h, and then you fully open up the top, clean up the top, and then factor out one h to get rid of the h on the denominator. So we have limit as h goes to 0. The top is 4 plus 2 plus 2 is 4, and then plus h squared plus 2 plus h plus 3 minus 9. And then take a look at the constant. We have a 4, 6, 9, and then we have a minus 9, right? So get rid of them. And then we divide it by h, and then we factor one h out. So limit as h goes to 0. Keep in mind, after you get rid of the constant, every single term left over has an h attached to it, so you factor one h out, then you have a 4 plus h and then plus 1, right? 4, okay, let me make sure this is right. 4 plus h plus 1. Okay, so that is just 5 plus h, and then you divide it by h. As you can see, the biggest enemy, the h in the denominator, is now gone. So as h goes to 0, we have a 5, right? So what is this called? This is called the slope of the tangent line. So this is called the slope of the tangent line at that point. Or you can just say this is the slope of the curve, the parabola, at x equals to 2. So how do you find the slope? How do you estimate the slope algebraically? The slope. How do you get phi algebraically? So the way we do this is we follow the limit definition of derivative. So let's follow the color. So we will just for numerically, so we will just follow the limit definition, and then we will shrink h to 0. So what is that mean? Shrink h to 0. So that means we will just try a very small h, because h goes to 0, right? I will do a 0.01 and then do one that is even smaller for a comparison. 0. How about this? 30. So what happened when we plug those in? Okay, when h is equals to 0.01, I will just use this piece, and then we will have a slope equals to 4, and then plus 0.01, and then plus 1, so that is 5.001, right? 5.01. And then what happened if you change that to very small, even smaller? So the slope is equals to 4 plus 0.0001, and then plus 1, that is a 5.0001, right? So as h goes to, as the h becomes so small, do you see that this piece is trivial as h becomes very small? So majority of the slope is determined by the 4 plus 1, which is equals to 5. So we make a conclusion and say as h goes to 0, and then the slope is just equals to 5. All right, so the slope is equals to 5. This is one of the ways to do it. I use this way. I think this way is smarter after you figure out the limit definition. But if you cover up the limit definition, I will try the way you use in average velocity. So alternatively, you can try this. So an alternate method, so other method, you can try what we did in average velocity. So you can do a y2 minus y2 minus y1, and then you will get to a similar conclusion. Okay, for average velocity, how about this? For average velocity, I would like to write this out. So for average velocity, we need 2 points, right? So the first point, number 1, we have that x is equals to 2, y is equals to 9. How about the other point? The other point, we add a small h to it. So in general, and that will be 2 plus h, and then the corresponding y-value is f of 2 plus h. So we have 2 points, and then we use the slope rise over 1. So the slope, we will do a y2 minus y1 divided by x2 minus x1. This is also called rise over 1 because we can draw these 2 points on the xy plane and then connect them using a straight line, right? So we start at a point and then, okay, here. The best way is to write out. So we have a curve. Suppose that is the parabola that we are looking for, and then this point is 2 comma 9, and then we add h step forward to reach to another point right over here. And then the rise over 1 is to find the slope of this secant line. Okay, so that is equals to f of 2 plus h, f of 2 plus h minus f of 9, not f of 9, minus f of 2, just write 9, right? Minus 9 divided by 2 plus h minus 2. Okay, so when h goes to 0, when h is very small, so think about like 0.00001. So what happened is you have f of 2.001 minus f of 2, and then divided by 2, and then all you have to do is you plug this into the given function. You will get something. This will just equals to the slope. I will just write this will be just approximately equals to 5. Okay, just like what we did using the algebraic method. And the easiest, and if you want to don't think of any of this, the easiest way ever, all right, the easiest way, no algebra, no calculus, no limit. The easiest way to think about this is you have 2 numbers, 7 and 7.001, a bunch of 0. What is the average of these 2 numbers? Since they are so close, you add them and then divide it by 2, the average is very close to 7. That is the easiest way to think about it without using any calculus. And even easier way is you have a curve, right? And then you have an h, and then you have a point, and then you add a little bit of h to reach to the next point. So since these 2 points, they are so close, the average is just equals to this point. Since these 2 points are so close, the average is just equals to the first point. Okay. All right. So that is the end of this video. If you like it, you think this is helpful, give me a like, share the video for me, subscribe to my channel if you are on your way out. I will see you all in the next lesson. Signing out.